All right, today we are going to talk about numbers in formulas and equations, a little bit of review, a little bit of this, a little bit of that, but it gets us started in the next unit. Okay, here are the objectives. Pause it, peruse it, if you so choose. All right, so let's review element and compound. What is an element? Well, here are some examples. It is a pure substance. So in that category for matter, we have pure substances and we have mixtures. Element is one example of a pure substance. All atoms of the same element have the same number of protons. So that means you can see from this visual, hydrogen has 1 proton, so all atoms of hydrogen have 1 proton. Magnesium has 12 protons, so all atoms of magnesium have 12 protons. It has a unique symbol. So aluminum has the symbol Al, capital A, lowercase l. It is found on the periodic table. So you're like, I wonder if that's an element. Well, let's pull up my periodic table and look. Just like that, they're also listed on table S. So that's an easy way to see if it is in fact an element. It has 1 capital letter, remember, sometimes has a lowercase letter. So you can see carbon, nitrogen, oxygen, hydrogen, sulfur. They do not have fluorine. They do not have a lowercase letter. The remaining elements that you see here do. So anytime you see a capital letter, it indicates, well, that's a new element, okay? Elements cannot be broken down by chemical means. And they have unique properties like their density, their melting point, their boiling point. A lot of those values can be found in table S. Elements can be bonded. So we can have a monatomic gas like neon, which has just single atoms, but we can have a diatomic gas like hydrogen, which has 2 atoms of hydrogen bonded. However, both of those atoms are still hydrogen, so it is still an element. Here's another visual. Diatomic nitrogen and helium is monatomic. So what are the diatomic elements? How do you remember them? Well, they're there on the periodic table. There's hydrogen. Now, remember the gases? We had nitrogen, oxygen, fluorine, chlorine, bromine. Okay, so it kind of follows the same pattern. So we have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And sometimes we count astatine, but I don't have a good mnemonic for that. But for the diatomic elements, I have one. Since it's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, have no fear of ice cold beer. Have H, hydrogen, no, N, nitrogen, fear, F, fluorine, O for of and oxygen, I for ice and iodine, C for cold and what? Chlorine, and B for beer and bromine. So have no fear of ice cold beer. Hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine. There you go. So what is a compound? Well, here are some visuals, some examples of compounds. A compound is also a pure substance. So remember, matter is broken into 2 categories, pure substance and mixture. 2 types of pure substances, elements and compounds. A compound is composed of 2 or more elements that are bonded. It has a unique formula with a definite proportion. It is not found on the periodic table, and it is not listed in table S. So if you're looking for the words and you look in table S, it's not there, then it's a compound. The elements are combined in a compound in a definite or fixed proportion. So that means H2O, water, is always 2 hydrogen and 1 oxygen, always. If it's not 2 hydrogens and 1 oxygen, it is not water. And a compound can be broken down by chemical means. Compounds, since they are pure substances, also do have unique properties like density, melting point, boiling point, etc. All right, is this an element or a compound? Compound. Is this an element or a compound? Element. And it's diatomic. You can see two atoms of the same element bonded. Is this an element or a compound? It's an element. It has multiple atoms, but they're the same element. So even though they're bonded, we are still an element. Is this an element or a compound? Compound. Is this an element or a compound? Element. This one is monatomic. One single atom. Nothing is bonded in this image. Is this an element or a compound? It's a compound. You can see different atoms of different elements bonded together. Is this an element or a compound? It's a compound. We have two different types of atoms. Is this an element or a compound? It's an element. A lot of atoms are bonded, but they're all sulfur, so it's still an element. Which substance cannot be broken down by chemical means? So cannot be broken down means it's an element. So which one of those is an element? Where am I going to look? Periodic table. If I can't remember the names, I'm going to check table S. The name that I see there is in fact an element, and this time it's aluminum. The compound is a substance composed of two or more elements that are what? Chemically combined in a fixed proportion. Let's review types of compounds. So we have covalent compounds. They're also called molecular. So covalent and molecular mean the same thing. Their electrons are shared. Their names have prefixes. And they're formed when two nonmetals bond together. The basic unit, if a compound has covalent bonds, it's called a molecule. So, but we can also refer to diatomic elements as molecules because they have covalent bonds. So this is a hydrogen molecule with two hydrogen atoms. This is an oxygen molecule with two oxygen atoms. This is a nitrogen molecule with two nitrogen atoms. This is a chlorine molecule with two chlorine atoms. To do an example of a compound, this is a molecule of this compound with one nitrogen atom and two oxygen atoms. Ionic compounds, remember, very strong bonds due to the attraction between positive and negative. The electrons in this case are transferred, so they go from one element to another. The names sometimes have Roman numerals, and they are formed between a metal and a nonmetal, or between polyatomic ions. So it could be a metal and a polyatomic ion, it could be a nonmetal and a polyatomic ion, or two polyatomic ions. So what's a polyatomic ion? Well, you have a whole list of them on table E, so good thing it's not a memorization thing. It means you have two or more atoms that are covalently bonded, right? And there's a positive or a negative charge. So for hydronium, for example, you have three hydrogens and one oxygen that are covalently bonded, and the whole group has a positive charge. Now, the basic unit when you have ionic bonds is called a formula unit. It is not called a molecule, okay? So if you have one Na and one Cl in sodium chloride, one Na and one Cl, that makes a formula unit. So formula units and molecules. We have ionic compounds that have formula units. Covalent compounds have molecules. Which terms identify two different categories of compounds? Can you find them? It's ionic and molecular, or it could have said ionic and covalent. Which term represents the fixed proportion of elements in a compound? Well, that's the chemical formula, like H2O. Now let's talk numbers, subscripts, and coefficients. These should not be new terms for you. So subscripts are the little numbers at the bottom. So right here, this is a subscript. So this 2 means there's 2 aluminum. This 4 means there's 4 oxygen. There's no subscript here. Anytime there's no subscript, it means 1. Okay, so in H2O, the 2 means 2 hydrogen. Since there's no subscript for the oxygen, it means 1. Okay, and then the letters, those indicate obviously what elements. This 3 outside here, this is usually where mistakes are made, if they are made. This 3 means there's 3 of what's in parentheses. So this 3 applies to the S and to the O. So think about it like the distributive property in math. So again, subscripts. No subscript, that means 1. Subscript, it tells you how many. When there's a subscript outside, it reflects everything inside the parentheses. Okay? Subscripts. No subscript, it's 1. Okay? Subscripts change the formula and change the substance. So you can't just willy-nilly go around changing subscripts because H2O is water, but H2O2 is hydrogen peroxide. You don't want to drink that, okay? CO is carbon monoxide, toxic, deadly gas. Carbon dioxide is CO2. So what are coefficients? You should know this term from math, but coefficients are numbers that are put in front of a formula. So in math, it's like if you have 2x, the 2 is the coefficient, okay? So coefficients are put in front of the formula. And it means there's 2 of that formula. So this coefficient right here means there's 2 of these. This coefficient means there's 2 of these. And again, just like subscripts, if there's no coefficient, it means 1. Just like x by itself means 1x. So coefficients just simply change how much of a substance. So this 2 means there's 2 of these. Visualize it. This 13 means there's 13 of these. Visualize it. This 8 means there's 8 of these. And here, visualize it. And this 10 means there's 10 of these. You can visualize it. So let's look here. Are there subscripts? Yes, there are. Are there coefficients? No, they're not. Since there's no coefficient written, it would be right here if it was. What coefficient is really there? Well, a 1, right? But we just don't worry about it. How many different elements do you see? Well, there's 3, N, H, and O. Are there any polyatomic ions? Well, yes, actually. So I'll look at table E, and it's NH4. That is a polyatomic ion. So which one? That's ammonium, NH4, with a positive charge. What are the subscripts for? So what's the subscript for oxygen? A 1, there's nothing written. What's the subscript for nitrogen? A 1, there's nothing written. What's the subscript for ammonia? That's the whole group, NH4. That's a 2. And what's the subscript for hydrogen? Well, that's 4. All right, so here you can see when you change the coefficient, if I put a 2 in front of the H2O, it simply means I have 2 water molecules. If I change the subscript, I change the substance. So when we do balancing equations later, never, ever, ever change a subscript. You can only change coefficient, okay? So let's practice. So when we count atoms, we have to use the subscripts, we have to use the coefficients, and we have to use the element symbols, okay? So here are some directions, but we're going to practice. Okay, so let's look at this one. How many atoms of each element are in this molecule? Sodium, does it have a subscript? So how many? 1. Carbon, does it have a subscript? 2. Hydrogen, does it have a subscript? 3. Oxygen, does it have a subscript? 2. All right, so let's see, how many atoms? So look at K, first potassium, does it have a subscript? 1. Chlorine, does it have a subscript? 1. Oxygen, does it have a subscript? 4. All right, let's count atoms here. So aluminum, how many? Well, this is tricky. See, we have a coefficient right here. So we have a coefficient here, and we have a subscript. So what we have to do is multiply them. So for aluminum, I have 2, but times 3. So altogether, I have 6. And let's switch colors. For oxygen, I have 3 in the formula. But this coefficient in the front still applies. So I have to multiply them. So for oxygen, I have 9. All right, so let's look here. Does carbon have a subscript? No, so that means it's a 1. You just don't write it. But this 5, this coefficient in front applies. So carbon has 5. Oxygen has a subscript of 2, but this coefficient of 5 applies to it as well, so it has 10. Whew, okay, so a lot here. All right, so this subscript of 2 applies just to aluminum. So aluminum has 2. No coefficient, so that means 1, so I don't have any extra multiplying. Sulfur, a little tricky. So inside, there's 1. You don't write the subscript though. But this 3 outside, like the distributive property, means I have to multiply whatever's inside by this. So there are 3 sulfur. So what about for oxygen? Well, this 3 applies, but oxygen has a subscript of 4. So it would be, okay, a lot going on here. So let's see if we can get it right. We have a coefficient. So that means this applies to the nitrogen, to the hydrogen, to the sulfur, and to the oxygen. Everything, no matter how much, gets multiplied by this 2. So let's start with nitrogen. Nitrogen has no subscript, so that's 1. But nitrogen is inside the parentheses, so this 3 applies to this nitrogen. So that makes 3. But then we can't forget about this 2, so that gives us 6 nitrogen. So what about hydrogen? Okay, well, hydrogen has a subscript of 4, so that would be 4, but this 3 applies, so that's 3 times 4, which is 12, but then again, this 2 applies, so 24 total. Okay, so now let's look at sulfur. Okay, just meant to change color. Sulfur. All right, sulfur has no subscript, so that's just 1, not in parentheses. So the only thing else that applies is this original 2 up here. So sulfur has 2. So what about oxygen? Well, oxygen has a subscript of 4. It's not in parentheses, but this 2, the coefficient, applies. So oxygen has 8. What is the total number of different elements in this formula? Well, it's 3. You might mistake and go N, H, N, and O, but the N is just in 2 places. It's not a different element. What is the total number of hydrogen atoms required to form one molecule of this? Okay, so we have hydrogen in two places. We have this, no coefficient in front, so that's just 5. But then we have this hydrogen inside here with this subscript, so that's 3. So we add those together. Altogether, we have 8. So let's look at equations. So equations are like recipes, right? So in order to get a s'more, you need 2 crackers, a marshmallow, 3 chocolate squares. That's the best kind of s'more. And that gives you 1 s'more. So what about the arrow? Well, the arrow divides the 2 sides of the equation, and we say the arrow as yields. Arrows can be in one direction only, pointing toward the right, and that means the equation is not reversible. If you have an arrow going in both directions, that means it's reversible. Equations also show states of matter. Not all equations are written with the states of matter, but they can be. So we have these symbols, S meaning solid, L meaning liquid, G meaning gas, and AQ meaning aqueous or dissolved in water. So when they're indicated in a formula, you can tell, oh, this is a gas, this is a gas, this is a liquid, okay? What is on each side of the equation? Well, left side we have reactants, right side we have products, okay? Left side we have reactants, right side we have products. Reactants, arrow. Equations can show energy. So exothermic versus endothermic. When it's endothermic, energy going in, energy will be a reactant. When it is exothermic, energy being released, energy will be a product. Okay, so when it's endothermic, energy is a reactant. When it's exothermic, energy is a product. When we break bonds, that's endothermic, just a reminder. When we form bonds, it's exothermic. So table I identifies reactions as endothermic or exothermic. At the bottom, it tells you a minus sign indicates exothermic. So every time you see a minus sign, that means it's exothermic. And when you get to one with a positive sign, that means it's endothermic. So if we have this equation, which statement describes this reaction? So we start with this, and energy is here. Energy is a reactant, so that means automatically I know it's endothermic. So that means these two are for sure wrong, okay? So what's happening? If I have N2 connected and then N2 plus N, so they're separated on this side, well, the bonds were being broken. Okay, is this exothermic or endothermic? Just look right here. See where energy is? Product side, exothermic. What about this one? Exothermic or endothermic? Okay, well, this doesn't have it written, so here's what I have to remember. So I'm going to draw real quick. Solid to liquid to gas. This I think about when I have to melt something. So if I have my gold necklace, and I want to melt it, it's going to take some energy in order for that to happen, okay? So going this way, going this way is endothermic. So going the opposite way would be exothermic. All right, so going from gas to liquid. So let's just switch colors so it's a little clearer. So going from gas to liquid, I went this way, which follows the exothermic arrow. So it's exothermic. All right, so this one, exothermic or endothermic. This one, you got to look at table I. So let me pull that out. Okay. and you look at table I to figure out the reaction. So consult table I, and I need to find N2 plus 3H2 and right here. So you got to check states of matter, okay? And then you go across and you see if it's a negative sign, exothermic, which in this case it is. All right, same for this one. I got to look at table I and find it. I got to check states of matter because it matters. It's not just random. And then I go across, and this one is endothermic. So equations can also show some reaction conditions. What do I mean? Well, it can tell you that you need to add heat by simply putting a triangle. It can tell you a specific temperature, putting an exact temperature in Kelvin or Celsius. It can tell you a pressure, and it can tell you the name of a catalyst that is needed to speed up the reaction. So let's look at a lot of it kind of put together. All right, so here's an equation. We have reactants on this side, products on this side, chemical formulas, states of matter, coefficients, subscripts. Arrow, which we say is yields. Here's another example. We have reactants to products. We have chemical formulas. We say yields for the arrow. We have coefficients and subscripts, a whole lot. So, goodness gracious, that was a lot about numbers and formulas and equations. So I hope you learned something new today.